Alright, hi guys, I know you're tired. Alright. Because it's already such a controversial subject, everybody has probably heard about animal testing. And it's been going on since the 1920s and has always been a black and white issue. My main proposition is due to technological advances, animal testing is no longer needed in society. I have 3 points to argue my point and also inform the audience. The first sub-point is animal testing procedures. The second sub-point is animal research facts. And the third sub-point is what are the animal testing alternatives. Okay, animal testing procedures. There are 5 main animal testing procedures. The first one is pure research, and it investigates how organisms behave, develop, and function. Now, this is looked down upon because it's basically researchers getting an animal, and it's basically like a free-for-all. There's no objective with this research. And this brings me to my second point, which is applied research, and this is an objective. This aims to solve a specific or practical problem. Then there's xenotransplantation, which researches, it helps research with organ transplants. And current research involves using monkeys as recipients of organs from pigs. My fourth animal testing research procedure is toxicology, which is also known as safety testing, and this is conducted by pharmaceutical companies for drug testing. And last but not least is cosmetic animal testing, which is probably the most controversial. It's still conducted in the U.S., and it just involves testing for eye irritancy, skin irritancy, stuff that irritates humans. Okay, animal research facts. In a study that spanned over 10 years and has not yet been repeated, the FDA began in 1976 to follow all the new medications it released for side effects. In this study, the FDA found that of 198 new medications, 102, 52%, were either recalled or relabeled secondary to side effects not predicted in animal testing. A similar study explained 6 drugs, the side effects of which were already known in humans. The study found that animals correctly predicted 22 side effects, but incorrectly identified 48 side effects that did not occur in humans, and 20 side effects that did occur in humans. This means that the animal models were incorrect 68 out of 90 times, or 76% of the time. In August 2001, Mark Levin, who has a PhD and is the CEO of Millennium Pharmaceuticals, presented data at the Drug Discovery Technology Conference in Boston. In his study, he presented 28 potential new drugs that were tested in rats for liver toxicity. Of the 28 drugs, 17 were found safe in rats, and 11 were found toxic in rats. Of the 22 that advanced to testing in humans, 17 were found safe in rats. Of those 17, 8 were found safe in humans, and 6 were found toxic in humans. And of the 11 that were toxic in rats, 2 were only toxic in humans, and 6 were still safe in humans. Levin concluded by saying that basically animals were about as accurate as a coin toss. In the Handbook of Laboratory Animal Science, Volume 2, the case of the huge 25-year screening program undertaken by the prestigious U.S. National Cancer Institute illustrates the kind of dilemma possible. In this program, 40,000 plant species were tested for anti-tumor activity. In the end, none of the drugs were found useful for therapy because of too high toxicity or ineffectivity in humans. This means that despite 25 years of intensive research and positive results in animal models, not a single anti-tumor drug emerged from this work. As a consequence, the NCI now uses human cancer cells for screening of cytotoxins. My third point are what are the animal research alternatives? One alternative is in vitro studies. In vitro is within the glass, and it is in a test tube or a petri dish. Basically, research that is done in a controlled environment. A 3-dimensional model of breast cancer has recently been developed that will allow investigators to study the earliest stages of breast cancer and test potential treatments. Rather than studying cancer in rodents, this model, which uses both healthy and cancerous human tissue, effectively allows the study of cancer as it develops in humans. Another animal testing alternative that is really successful is clinical investigating. Those who experiment on animals artificially induce disease. Clinical investigators study people who are already ill with natural occurring diseases or who have died. Animal experiencers face the unavoidable fact that their artificially created animal model can never fully replicate the human condition, whereas clinical investigators know that the results of their work are directly relevant to people. In conclusion, I've explained all the different types of animal testing. I've provided some shocking facts about animal testing, as well as explaining the lower costing and higher overall efficient animal testing alternatives. If we have cars being made that have internet access and phones being made where you can see a three-dimensional picture on a two-dimensional screen, why are we still stuck in the 1920s? Thank you.
All right, I'll start with the evidence. You're pretty consistent about citing the information. I like the one author that did all the statistical comparisons and talked about the results. There's so much of it that you're having to go through that it gets a little complicated, but ultimately at the end, you've got a piece of testimony that summarizes it pretty well, equivocating it to being as useful as a coin toss. The NCI example, I think, is a good example to illustrate the problems that people have in particular fields with animal testing, at least, and I thought that worked fine. On the first point where you're outlining all the different kind of testing, I'm not sure that you talk about all the different types of testing with the evidence that you present later on, so I'm not sure why you bothered to go through all of those particulars, especially if you're not talking about cosmetic testing, for instance, or some of the other kinds of testing that that have to do with surgery. I think the stuff about drug testing makes the most sense on your comparison. And I like the fact that you were pretty consistent about citing all the information. All right, I like your exit line too. Thank you.